Hi, welcome once more to Mr. Max. In this lesson, we are going to revise from September 2022 Kwa-zulu Natal province question. September 2022 Kwa-zulu Natal sequence and series questions. Okay, so listen very carefully. That is question number 2, 3, and 4. Okay, so let's start to question number 2. Given the quadratic number pattern, so there is a quadratic number pattern given like this: 5, 9, 17, 29, etc. Okay, so there is a quadratic pattern given like this, and we have to answer the remaining questions based on that one. Okay, so if it is a quadratic number pattern, of course we can find a common second difference. Am I right? Okay, so how can we find the second difference, guys? Here, how can we find the second difference? You have to subtract 9 minus 5, that is 4. 17 minus 9, that is 8. 29 minus 17, that is 12. Okay, then second difference, how can you find the second difference? 8 minus 4, that is 4. 12 minus 8, that is 4. Can you see that the second differences are the same because this is a quadratic sequence? Okay, now what is the first question? 2.1. Question number 2.1. What is that question? Write down the fifth and sixth term of the pattern. So here we can see that this is first term, second term, third term, fourth term, and you have to write the fifth term and sixth term. That is the question. Okay, so what are the terms here? What is the number here? What's the number here? That is what you want to find. Okay, so how can we find that one? Now, if it is a quadratic pattern, here second differences are the same. So it means here it is 4, here also it is 4. So how can I find these numbers? How can I find that numbers? Look at this. 4 plus 4 is 8. 8 plus 4 is 12. So what is this number? 12 plus 4, that is 16. 16 plus 4, that is 20. So the numbers are 16 and 20 here. Now we have to find these two numbers. That is the question. Okay, so 5 plus 4, 9. 9 plus 8, 17. 17 plus 12, 29. So next one is 29 plus 16. So what is 29 plus 16? 39, 45. Then 45 plus 20. That is the next number. 45 plus 20 is 65. Like this, guys. 5 plus 4, 9. 9 plus 8, 17. 17 plus 12, 29. 29 plus 16, 45. 45 plus 20, 65. So the fifth term is T5. That is 45. And the sixth term is 65. Okay, so that is the first question, 2.1. Now let's move to the next question, 2.2. Question number 2.2. What is that question? Show that the nth term of the quadratic pattern is given by Tn is equal to that one. You have to show like that. So it means that you have to find the nth term. That's all. Okay, so what is the general equation of a quadratic pattern? An square plus bn plus c. Right, this is the general equation, and here we have to find the values of this a, b, and c. Right, so how can we find the values of a, b, and c? We have to call this one as 2a and this one as 3a plus b, and this one given series as a plus b plus c. Am I right? Okay, so let's start from here. 2a is equal to 4. 2a is equal to 4. So what is a from there? 2 times. So if I want to take these 2 to the other side, it is division. So it is 4 divided by 2. So 4 divided by 2 is 2. So it means that we got the value of a as 2. Now take the second equation. What is the second equation? 3a plus b is equal to 4. What is the value of a? It is 2. So it is 3 times 2 plus b is equal to 4. 3 times 2 is 6. So if I take that positive 6 to the other side, it is negative 6. So it is b is equal to 4 minus 6. So what is b? 4 minus 6 is minus 2. So we got the value of b also. Now what we have to find? C. So we have to take the third equation. What is that equation? A plus b plus c is equal to 5. So what is the value of A? It is 2 plus what is the value of B? Minus 2 plus C is equal to 5. What is plus times minus? Minus. So it is 2 minus 2 plus C is equal to 5. Am I right? Okay. So here positive 2 and negative 2, what we can do? We can cancel. So what is remaining? C is equal to 5. So we got the value of C also. Now we can substitute in this equation. This is our general equation. So what is Tn? Tn is equal to an square. What is A? It is 2. 2n square. What is B? Plus B. B is minus 2. Okay. So plus minus 2n plus C. C we got it as 5. So 5. So once more, Tn is equal to 2n square plus minus is minus 2n plus 5, and that is what we want to prove. Am I right? Look at the question. We want to show that Tn is equal to 2n square minus 2n plus 5. So we got the answer, general term. Okay. So that is question number 2.2. Now we have to move to the next question, 2.3. Okay, let's move to the next question, 2.3. What is that question? Is 2023 a term in the pattern? Motivate your answer. So what is our pattern? 5, 9, then 17, 29. We know it, next one is 45, 65, etc, 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 etc. Now they are asking 2023. Is this one is a term in this pattern or not? That's what you want to find. Okay. So that 2023 is a term in this pattern or not. So what we have to do is we have to assume that this 2023 as a Tn. Okay, the last term or nth term. Okay, then from there we have to find the value of n. Listen very carefully. Assume that last 2023 is Tn, that is a term. Okay, then we have to find the value of n. So if we are getting the value of n as a natural number, for example, if we are getting let's say 30, that's a natural number, then we can say that the 30th term is 2023. Okay, or if you are getting n as a 28, then we can say that 28 is a natural number, so we can say that the 28th term is 2023. Okay, but if we are getting n is equal to 30.4, then that 2023 is not this is not a natural number. Okay, then this 2023 is not a term in that sequence. Why? Because we are talking about the term, first term, second term, third term, fourth term. Okay, 30th term. Then after 30th term, which term is that? 31st term. Is there any 30.4th term? No. So if you are not getting a natural number, then it's not that 2023 is not a term in that sequence. Okay. So for another example, n is equal to minus 28.5. Then also it's not a term, because we can't say that minus 28.5th term. There is no minus term there. Okay, first term, second term, third term, fourth term, etc, like that, positive numbers. Okay, so anyway, we have to find the value of n. So assume that 2023 is our Tn. Okay, so what is our equation Tn? Previous question we got, or in fact that is given in the question, 2n square minus 2n plus 5. Am I right? This is our Tn. Okay, so here we have to substitute the value of Tn as 2023. So 2023 is equal to 2n square minus 2n plus 5. So let me write this one on the left side and this one on the right side. Okay, so 2n square minus 2n plus 5 is equal to 2023. I just swap it around. Okay, just to write a quadratic equation on the left side. Okay, take this one to this side, left side. So it is 2n square minus 2n plus 5. This positive on the left side, it is minus 2023 is equal to 0. 5 minus this one, check in your calculator, what is answer? 2n square minus 2n, 5 minus 2000, that is minus blah 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 2000, what is this one guys, 2018 is equal to 0. So now look at this one, this quadratic equation 2 is a common factor, so we can divide throughout with 2. So what is the answer now? 2 by 2 is cancelled, so it is n square, 2 cancel, minus n, minus, check in your calculator, what is this, 1009 yeah, is equal to 0. So now we have to factorize this one. So here the number is too big, so we can apply the quadratic formula. Okay, so what is the quadratic formula guys? To find the n, here not x, so here we are the variable is n. Okay, so to find n we can apply the quadratic formula, minus b plus or minus square root of b square minus 4 into a into c. I hope you know this quadratic formula, 2 into a, am I right? Okay, so apply the quadratic formula, n is equal to minus b. So here what are the values of a, b and c? A is 1, b is minus n means minus 1. Okay, then c is minus 100 and 1009. Okay, so here we can substitute the values. B, what is b? Minus 1 plus or minus square root of b square minus 1 square minus 4 into a, what is a? 1 into c minus 1009 divided by 2 into a is 1. So now you have to use your calculator. Okay, you just write one more step simplified. Minus into minus is plus 1 plus or minus square root of minus 1 square, minus 1 square is also 1. Then here look at this one, all of these are multiplication, so minus times minus, that is positive, so it is 1 plus 4 times that you have to find the answer in your calculator, 1009 divided by 2 into 1 is 2. So check in your calculator for both the answers, that is one answer for plus, okay, and the other one is for minus. Check in your calculator, what are the answers? 4 times 1009 divided by 2.1, 32.27. 32.27. And what about the answer for the next one, minus? This minus, you just change that one as minus, minus 31.27, minus 31.27. So now look at the values of n. 32.27 is not a natural number, minus 31.27 is not a natural number. You understand? So it means that this 2023 is not a term in this sequence. You understand? If it is a term, then either we are supposed to get a 31st term or 32nd term, like that, okay, or 33rd term or 34th term, not 31 point, there is no such a term, 31.27 the term. Which term is that? We know only 31st second term and 33rd term, 32 and 33rd, 33, am I right? Okay, there is no term between that. So it means that it implies that n is not a natural number. Therefore 2023 is not a term in the sequence. Therefore 2023 is not a term in the sequence. Okay, so that is question number 2.3. now let's move to the next question, question number 3. Okay, question number 3, sigma, evaluate sigma k is equal to 1 to 50 30 minus 4k. This is what you want to find. Okay, so sigma means sum, k is equal to 1 to 50. Okay, so first you have to substitute the value of k as 1, then 2, then 3, then 4. Am I right? Okay, that's how you want to find the answer of that one. Okay, so substitute the values. k as 1, 30 minus 4 into 1, like this, 30 minus 4 into 1. So 30 minus 4, 26, plus, why it is plus? Because it is sigma. Sigma stands for adding. Okay. Then next k is 2. That means 30 minus 4 into 2. 4 into 2 is 8. So 30 minus 8 is 22, plus next one, k is equal to 3. So 30 minus 4 into 3. So what is that one? It is 18. Am I right? Check in your calculator. Okay. 12, 20, 18. 18 plus etc. Okay. And what is the last term? 30 minus 4 into last term is what? Last term is 50. Okay. So 30 minus 4 into 50, 200. 30 minus 200 minus plus minus 170. So the last term is minus 170. Okay. Now we have to find the, so what type of series is this? What type of sequence is this? Is an arithmetic sequence. Can you see? You can find a common difference. 22 minus 26. What is answer? Common difference. Minus 4. Am I right? 22 minus 26. That is minus 4. Here minus 4. Here minus 4. So it is a arithmetic sequence. So what is the formula to find the sum of an arithmetic sequence? You know two formulas. One formula is this one, Sn is equal to n over 2 into, this is a common formula, 2a plus n minus 1 into d. Normally we are using this formula. Okay. There is another formula to find Sn, both the same thing. Okay. What is that formula? N over 2 into a plus l. What is this a and l stands for? First term and the last term. So if we know the first term and last term, this is easy to find the answer. First term is 26 and the last term is minus 170. So we know the first term and last term. So we can use that formula. Doesn't mean that you can't use this one. You can use, you will get the same answer. Okay. So here Sn is equal to n. How many terms are here? 1 to 50. 1 to 50 means there are 50 terms. Okay. So it is 50 divided by 2 into a. What is the first term? 26 plus L minus 170. So plus minus is minus. So check in your calculator what is answer for that one. Minus 3600. Minus 3600. So that is the answer for question number 3.1. Okay. Now let's move to the next question. Question number 4. Question number 4. Given the geometry series, question number 4.1, given the geometry series AR square, AR cube, where A is the first term and R is the common ratio, prove the sum to n terms of this series is given by Sn is equal to, yeah, we know that formula, sum to n terms of a geometry series. Okay. So here what is the sequence given? A plus AR square, AR cube, like that. Okay. So Sn is equal to A plus, what is the sequence given? AR square plus AR cube plus etc etc etc. Then the last term is AR raised to n minus 1. Okay, that is the last term. Now let me write it here, etc plus AR raised to n minus 1. Okay, that is the last term. Okay, so this is Sn. Okay, now we have to prove that sum formula. What is the sum formula? We already by hearted that formula. Am I right? A into R raised to n minus 1 divided by R minus 1. So in this question we have to prove, it's like a theorem. Okay, we have to prove this theorem. How do you get this formula? Okay, so this is a general term for a geometry sequence. A plus second term is AR square plus AR cube plus etc. and the last term is AR raised to n minus 1. Now from there we have to prove how to find the sum. This formula we have to prove. Okay, so for that I'm going to call this one as equation number 1. Okay, now what I'm going to do is equation number 1 I'm going to multiply with r. Okay, so I'm going to multiply both the left side and right side with r. Okay, so r into Sn. Am I right? So here also I'm supposed to multiply the whole of that thing with r. A plus ar square plus like that. Okay, so plus a into r raised to n minus 1. I multiply that one with r. Okay, so I'm not going to write that step there. Okay, so look at this one. After I multiply with the r both the left side and right side, okay, I am supposed to expand this one, r into a, that is ar. Okay, then r into ar square, that is ar cube. Am I right? R times, and I multiply these two. Okay, r times ar square, that is r into r squared is r cube. Am I right? Okay, then the next one, r into ar cube, r into ar cube, so it is ar raised to 4. Okay, so here I'm not going to write it like this. I'm directly going to write with that multiplication expanding in the bracket. Okay, so here what is that one? Multiply both the sides with r, so it is a into r, ar. Okay, where is my ar term? A plus ar plus, this is ar and this is my ar square. Okay, so I'm going to multiply with the r. So r into, first term is here also r into a, that is ar. Okay, so that ar, like these guys, like what I wrote before, the whole of the right side I am supposed to multiply with r. So r into a plus ar square plus etc plus ar raised to n minus 1. So r into a, that is ar. So that one I am going to write under this ar because these are same term. Okay, then r into ar, is it not that ar square? R times r is r square, so it is a, so it is a r square plus, okay, etc. Okay, now this one, r into r times a into r raised to n minus 1. You have to multiply this last time also. Okay, so r times, so here it is 1. So we are supposed to exponential rule 1 plus n minus 1. That what is that? A into r raised to n minus 1 plus 1. This n minus 1 plus 1. You have to add the exponents. So here minus 1 and plus 1 cancel. What is that? A into r raised to n. So the last term is a into r. So the last term I am going to write it here. A into r raised to n. Okay, so if this one is a into r raised to n, try to understand that the term just before that one, that is also, this one is a into r raised to n minus 1, because when we multiply here this r with this one, we got a r raised to n. That is the last term in this second one. Okay, and the last term I wrote it here. Okay, so in this sequence, in this series, what is the term just before this a into r raised to n? That is a into r raised to n minus 1. Why I wrote it like this? Because I want the same terms together. That is why I wrote this last term here. I didn't write it here. You understand? But I know that once if I write the last term here, I know that the previous term is a into r raised to n minus 1. Okay, so I call that one as equation number, this one as equation number 2. Okay, now what I am going to do is equation number equation number 2 minus equation number 1. Okay, so I'm going to do equation number 2 minus equation number 1. So when we are doing like this, we have to add or subtract term by term. Okay, so this is equation number 2. So left side minus left side, that is r into Sn minus this one Sn. Am I right? Okay, so is equal to, here there is nothing there, you see that there is nothing here. Okay, so I can write a plus 0 here. Am I right? 0 plus ar. Okay, why I wrote it like this? Because I want this ar squared on the same position. Okay, that is why instead of writing starting here, I wrote it here. Okay, so what is 0 minus a? That is minus a. Am I right? Okay, so here it is minus ar minus ar, that is 0, ar square minus ar square, that is 0, plus etc. ar raised to n minus 1 minus ar raised to n minus 1, that is 0. Okay, then plus ar raised to n, here there is a plus 0 we can put. Okay, so ar raised to n minus 0, so it is ar raised to n. Okay, so what is remaining? Only this last term and the first term is remaining. Okay, now look at this one. Okay, let me write once more. R into Sn minus Sn is equal to minus a, let me write that one first, a into r raised to n, then this term minus a. So look at the left side. Is it not Sn a common factor? So take that Sn as common factor. So what is remaining? R minus, if I take Sn as common factor, remaining is 1. Okay, is equal to, here these two terms, a is a common factor. So what is remaining? R raised to n minus 1. So from here, what is Sn? Sn is equal to, this is multiplication. So if I want to take this one to the other side, it is division. It will come here in the denominator. So already there, a into r raised to n minus 1 divided by r minus 1. And this is the formula, you know this formula, to find the sum of a geometric series, and that is the question. We have to prove that one. Okay, so this one, as it is like a theorem in Euclidean geometry, you studied so many theorems. Okay, so like that, this one as it is you have to study. There is a chance to ask this type of questions. Here this is for geometry series. Similarly, there is a theorem to prove arithmetic sequence. Okay, so when we do another question, when that question comes, I will explain how to prove arithmetic sum. Okay, Sn, what is that formula for arithmetic sequence? Sn is equal to n over 2 into 2a plus n minus 1 into d. This formula also you have to prove something like this. Okay, so that is question number 4.1. Now let's move to the next question, question number 4.2. First two terms of a geometry sequence with the constant ratio and an arithmetic sequence with the constant difference d is the same. What is the meaning of that question? 4.2. Okay, the first two terms of a geometry sequence. Okay, so there are geometry sequence and arithmetic sequence. Okay, so they are saying that the first two terms t1 and t2 of the geometry sequence. Okay, and what is the common ratio in this geometry sequence? The common ratio is r. Okay, and here what is arithmetic sequence? Common difference is d. Okay, so in this geometry sequence and arithmetic sequence, they are saying that the first two terms are the same. Here geometry sequence t1 and t2 and arithmetic sequence t1 and t2. In that arithmetic sequence and geometry sequence, the first two terms of the geometry sequence and arithmetic sequence with the constant difference is the same. That means this first term and second term is the same as this one and this one. Okay, so what about before I move to the next sentence, first question, so if these two terms and these two terms are the same, so it means that the sum of these two terms and the sum of these two terms are also the same. Did you understand? Guys, here they are saying that first term and second term are the same here and here. Okay, so for example, here it is first term is 2. Okay, and here the first term is 4. Okay, so what is here? First term is 2 and the second term is 4. Do you understand? Okay, so what is 2 plus 4? 6. What is 2 plus 4? 6. That means if the first term and second term in geometry sequence and arithmetic sequence are same, means that the sum of that geometry sequence first term and second term and the sum of first term and second term of the arithmetic sequence are also the same. You understand? Okay, just leave that one there. Now, what is the first question? There is one more term. The first term is 12. So it is given that the first term is 12. So what is the first term here? This one is not 2. This is just an example. Okay. So here they are saying that the first term is what? It is 12. Okay. So now what is the first question? 4.2.1. 4.2.1. So here also the first term is what? It is 12. Okay. Okay. Now write down the second and third term of each sequence in terms of D and R. So you have to write what is the second term and what is the second term here also. You understand? So since this one is a geometry sequence and the common ratio is R, so how can I find the second term? Geometric sequence. So geometry sequence first term is 12. Okay, so how can I find the second term? 12 times the common ratio, that means 12 times R, that's all. Okay, so here it is 12 R. You understand? Then arithmetic sequence. So first term is 12. So how can I find the second term? The common difference is D. So how can I find the second term? That is 12 plus D. Am I right? Okay, you have to add the common difference to get the next term. For example, 3, 7, 11. This is an arithmetic sequence. So first term is 3. How can I find the second term? What is the common difference here? 4. So it is 3 plus 4. You have to add the first term plus common difference. So here the common difference is D. So it is first term plus common difference, that is 12 plus D. That's all. Okay. Okay. So that is the first. So what is the second term? 12 plus D. So that is 4.2.1. Okay. You have to write down the second and third term. Oh, you have to write the second and third term. So now third term, this is the first term, this is second term. So how can you write the third term here? 12R. Next one is 12R square. Am I right? At the geometry sequence is going like that. Okay. AR square, AR cube is going like that. Okay. So 12R square, 12R cube, like that. Okay. Then here arithmetic sequence, how can you write the third term? 12 plus then 2D. Do you remember arithmetic sequence is going like this? A plus D, A plus 2D, A plus 3D. It's going like that. Am I right? Okay. So here first term is 12. So second term is 12 plus D. Third term is 12 plus 2D. Okay. So here what are the geometric sequence? Let me write it here. Geometric sequence. What are the terms? 12, 12R, 12R square. First three terms. Okay. Arithmetic sequence. What are the terms? 12, 12 plus D, then 12 plus 2D. Okay. Those are the first three terms of arithmetic and geometric sequence. Okay. So that is question number 4.2.1. Now 4.2.2. Question number 4.2.2. What is that question? If it is further given that the sum of the first, listen, read that question very carefully. If it is further given that the sum of the first three terms of the geometry sequence is 3 more than the sum of the first three terms of the arithmetic sequence. What is the meaning of that sentence? Sum of the first three terms of this geometry sequence. What is that one? 12 plus 12R plus 12R square. This is the sum of the first three terms of the arithmetic geometry sequence. Okay, is, look at that sentence once more, is 3 more than the sum of the first three terms. 3 more than the sum of the first three terms. Okay, 3 more than means what is the sum of the first three terms of arithmetic? 12 plus D plus 12 plus 2d, then 3 more than, that means plus 3. Don't be confused there. Okay, so this is the, wait 1 second guys, 3 more than, that means this is the sum of first 3 times of the arithmetic sequence, 12 plus 12d plus 12d, 12 plus 12 plus 12 plus d plus 12 plus 2d, 3 more than, that means plus 3. You understand? Sum of the 3 terms of the geometry sequence is 3 more than the sum of the first 3 terms of the arithmetic sequence. Okay, so now what you want to find? What is the question? Determine the two possible values of the common ratio. You have to find the common ratio. Okay, so that is a question. So here we can simplify this one. So here 12 is a common factor, am I right? So it is 1 plus r square. Here addition, so 12 plus 12 plus 40, 24, 36, 39. So it is 39 plus, what about the d term? D plus 2d, that is 3d. Okay, so here 3 is a common factor, am I right? Okay, so here 12 into 1 plus r square is equal to, if I take 3 as common, let me write this d first, d plus 39, 3 common factor, so it is 13. So here if I divide both sides with 3, what is going to happen? Divided by 3, divided by 3. So these 3 and 3 cancel. 12 divided by 3 is 4. Okay, so what is d plus 3, 13? So let me write this one first. D plus 13 is equal to, what is remaining here? 4 into 1 plus r square. Okay. Now look at the first sentence given in the question. It is given that the first 2 terms of the geometry sequence and the first 2 terms of the arithmetic sequence are equal. Am I right? Okay. So there I told you, if the first 2 terms are equal, it means that the sum of the first 2 terms are also equal. Am I right? So here, from here, what we can write? 12 plus, from here what we can write? So let me call this as equation number 1. Okay. So from here 12 plus 12r is equal to 12 plus 12 plus d. Am I right? Okay. So here 12 plus 12 is 24. So 12 plus 12r is equal to 24 plus d. So if I take this 24 to this side, it is d. Am I right? Okay. So 12 plus 12r, take this 24 to this side, so it is minus 24 is equal to d. So what is d? 12r, 12 minus 24, 12 minus 24 is minus 12. So I got an expression for d guys here, that is equation number 2. Okay, now look at this one, there is a d here. So what I can do, I can substitute this equation number 2d in this equation. You understand? Okay, so I'm going to do that one now. So equation number, substitute equation number 2 in equation number 1. So what is that one? This is d. So d plus 13, what is d? 12r minus, sorry, not 12 minus r, 12r minus 12. Okay, so 12r minus 12 is equal to, sorry, d plus 13. So plus 13, I substitute the value d as 12r minus 12. Okay, plus 13 is equal to, what is remaining? 4 into 1 plus r square. So now we have to simplify this one. Okay. Oh, okay, there is no need to take the common factor here. We can multiply and make it as a quadratic equation. Okay, so 12r minus 12, what is minus 12 plus 13? We don't want to write it again, the same thing. 12r minus 12 plus 13 is plus 1. is equal to 4 into 1, 4. 4 into r, 4r. 4 into r square, 4r square. Okay, so here we can make it as a quadratic equation. Take everything to the right side. So here it is 0, 4 plus 4r plus 4r square. Take this one to this side, so it is minus 12r. Take this plus 1 to this side, minus 1. So here 0 is equal to, let me write it in order, 4r square, 4r minus 12r, that is minus 8r. 4 minus 1, that is 3. So 4r square minus 8r plus 3, that is the equation. Okay, so now we have to find the value of r. We have to factorize that one. Okay, how can we factorize this one? So let me write it in order. 4r square minus 8r plus 3 is equal to 0. Okay, so now what are the factors, guys? It is 2r and 2r. Yeah, 2r minus 3 minus 1. Yeah, minus 1. So that is a factorization. Okay, so you have to know the factorization, this one. Okay, so here 2r minus 3 into 2r minus 1 is equal to 0. I factorize this one. Okay, so it means that either 2r minus 3 is equal to 0 or 2r, this one, is equal to 0. 2r minus 1 is equal to 0. So 2r is equal to 3, r is equal to 3 over 2. And here 2r is equal to 1. What is r? 1 over 2. So we got two values of r, that is 3 over 2 and 1 over 2. Okay, so that is the question. You have to determine the two possible values of the common ratio. Okay, so guys, that is 4.2.2, and that's a little bit tricky question, so you have to watch again and try to understand that one. Okay, so one advantage is when you practice this type of questions, okay, above average question, you will get different ideas. So when you write your exam, if you have a similar question like this, you can answer. Okay, so anyway, that is September 2022 Kwa-zulu Natal question. So I hope you followed this class. Thank you for watching. Keep on watching, and then see you on the next lesson.